Okay, ladies and gentlemen, if you're seeing this, that means I am not here and we're presenting lesson number 30, complex numbers, day 2, multiplying and dividing. You will be given, obviously, your notes, and then as you go through your notes, you see there are some worked out examples showing you multiplication and division as you go through. What I want to present to you today is not the worked out examples, which are there to follow along with, but numbers 5 and 6, and then onto the next page, examples in the previous 11, 12, and 13. So let's get started with these. Right here, it's asking us to compute 5 minus 2i times 1 plus I. Well, I FOIL, and I FOIL, not forgetting my negative. And I'll end up with 5 times 1, plus 5i, 5 times I, negative 2i times 1, minus 2i squared. Now, as you have read through the notes, you'll see examples of this where we end up with an I squared at the end. The I squared, depending on where the other I is, will always turn into the I squared will turn into negative 1. So what's really happening here is you really have negative 2 times negative 1, or plus 2. Okay? Your two I values here are going to go together. They will create the 3i. And then the 5 comes down. 5 plus 2, of course, is 7, plus the 3i, giving us 7 plus 3i. You'll find this same thing worked out for you on your answer key that you picked up when you walked in. For number 6, FOIL again. Now these are conjugates. How do I know they're conjugates? Because they have a difference of a plus sign or minus sign in the middle. And as you saw when you went through your notes, the conjugates now allow you, here we are, 49, to have middles that will be additive inverses of each other. And again, this becomes negative 4 times negative 1, or positive 4. The 49 comes down. And what happens is these add up to make 0i. So the result here is 53, because that falls out. Now, technically speaking, as a complex number, you could write 53 plus 0i, but 53 is good enough. Now, as we go into the division section, conjugates are very important. You're always going to multiply your denominator by your conjugate. And you'll see that in your worked out examples. There's the division rule, again, just in case you forgot. This is very similar to how we approached doing radicals, where we had a radical in the denominator for a binomial. I'm having to use the conjugates to get it out. Example 7, example 7, example 8, example 9, example 10. All of these are worked out for you on your sheet. Let's take a look at example number 11. Now, number 11, again, this is now on in your answer key as well, gives us 5 over 2 minus I. So 2 plus I and 2 plus I. The denominator becomes 4, and since it's a conjugate, we know the middles fall out, minus I squared. The top, for now, I'll leave it as 5 times 2 plus I, just for now. If I need to, I'll distribute. It's not a big deal. This 4 stays the same. We know this turns into the minus of negative 1, which is plus 1. And we end up at 5 times 2 plus I, all over, in this case now, a 5. So by not distributing, I actually had dealt with the fact that we're going to simplify. So now, as I cross out my 5s, my result is going to be 2 plus I. Number 12 gives us 4 plus 2i on the top and 3 plus 5i on the bottom. And what we're going to do here is we're going to multiply by the conjugate 3 minus 5i. Now you're going to need to FOIL out the top, and we're going to do the bottom first though, because again, using the conjugates allows me to now get 9 minus 25I squared on the bottom. So on top, if we FOIL this out, 4 times 3 is 12. 4 times negative 5I is negative 20I. 2I times 3 is positive 6I. And 2I times negative 5I is negative 10I squared. Right? We know this is going to turn into a plus 25. Why? Because that I squared is negative 1. It's negative 25 times a negative 1 gives me positive 25. This right here will turn into plus 10 because it's the I squared is negative 1. Excuse me, negative 1 times negative 10 is 10. So you end up with 12 plus 10, that's 22. Negative 20 plus 6 is negative 14I. And all of that is over 9 plus 25 is 34. Everyone has a 2 in common, so we can simplify this and divide everything off by 2. We get 11 minus 7I all over 17 as our final answer. And again, you can see that again worked out for you in your answer key. It's on the back of the first sheet. The first sheet is examples 5 and 6. 11, 12, and 13 are on the back of that. Obviously, the additional sheet there is the answer key for the homework, so you can go through as you check. So no need for people to be running up trying to grab the key. Okay. Last one says, what is the multiplicative inverse / reciprocal of 4 plus 3I? Now, I'm not looking for the conjugate here. I'm looking for the reciprocal, which means flip it over. So it's 4 plus 3I on the bottom now. So we multiply this by 4 minus 3I, 4 minus 3I. Now, obviously the conjugate is being used, but I'm not just looking for the conjugate. I'm not looking for the additive inverse. I'm looking for the multiplicative inverse. So the top stays the same because anything times 1 is itself. The bottom we have our conjugate, so the 16 minus 9I squared. 9I squared turns into plus 9. 4 minus 3I on top. The bottom is 16 plus 9. 16 plus 9, of course, is 25. And that's our answer because nothing simplifies from there. Now, obviously, you're going to need to practice working on these. What we will do is the next lesson will be a practice on all of the complex and imaginary number work we've been doing. I would like you to start the homework and work on that as well. If you have trouble with this, of course, you can review this video anytime. It's right on my YouTube channel. And I'm also included, obviously, the work itself right from my answer key for you to have as an answer key for there. Thank you for cooperating. See you all later.